Okay, started.
All right, so good morning, good afternoon. This is the volume Populators Kubernetes SIG storage meeting. Let me share my screen. So, as we talked about last week, we're pretty happy with the the first week we kind of agreed that we wanted to go with the storage with the controller approach instead of the validating webhook. And then last week we went into detail about how we may implement actual populators in terms of what they're going to do with the Kubernetes API layer. And we spent a little bit of time talking about once we have like a prototype of that working, how we can sort of scale it out for multiple populators and try to get code reuse, because it became clear based on the discussion around wait for first consumer and some other sort of sticky details around getting volume provisioning in Kubernetes right in general, that we don't want people re-implementing that code over and over. We want one copy of it that just works, that can be reused. But we didn't get time to go into that last week. So that's kind of the main thing that I'd like to cover today, unless people have anything else they wanted to add to the agenda. Nothing? Okay. So the first thing that, well, I mean, okay, let me take a step back. The pattern we've followed so far when we wanted to reuse code in SIG storage has been, we write these sidecars, and then we have like a plugin and a sidecar container, and then they talk to each other over gRPC, and the community maintains the sidecar, and individual vendors implement plugins, and it seems to be a good model for CSI, and it seems to be the model that Cozy is ultimately going to follow. That was my first thought here, but I realized that if we were to do that, like we would need to implement like a full-blown gRPC spec a la CSI, which would mean like its own repo, its own gRPC spec, probably some sort of document describing how to use it. The sidecar would have to conform to that. The populators would have to conform to that. It seems like a very heavy approach to sort of integrating the shared code and the populator specific code. So what I wanted to sort of, well, I guess think about today was, can it be done as a library where we implement all the code in like some sort of just a repo that can be imported into other projects where, you know, you provide like sort of a sample, and then you import all of the boilerplate code, or I mean, sorry, the sample would contain the boilerplate code, and you would import this library that would do most of the actual work, and then you would just implement little bits of code. What do people think of that kind of approach, and are there any examples that we could follow if we wanted to go down that path?
So examples of that, I think, are the old external provisioner code, the original one, the OG code that lived in that old repo. And we could follow that model. I think we considered doing that with Cozy. I think ultimately what it comes down to is kind of the hardship on us as maintainers and developers of this code versus the hardship on the folks that are going to be doing the integrations and writing these plugins. And so I think we tend to want to lean towards, let's take on the burden of the work and make it as easy as possible to develop the plugins. And in general, the pattern that we've seen is that it becomes a lot easier to do these integrations and keep them maintained if the Kubernetes bits are kind of all nicely wrapped away in its own container, and there's a clear, you know, gRPC interface with the backwards compatibility contract, versus a library that may have, you know, backwards incompatible changes potentially, and it's harder to kind of keep track of, oh, what version am I on, and just a little bit more
Well,
difficult to integrate potentially.
Yeah,
okay.
I agree with Saad. I think with CSI or in general with sidecars approach, it's we can definitely the line we can draw is like the sidecar implements all the Kubernetes related logic, and the actual driver implements Kubernetes sort of agnostic logic related to a driver itself. I'm not sure at this moment, while we don't have really good understanding of what driver, what we can generalize and what should be a responsibility of individual drivers. I think at this stage might be a little bit too early to say what kind of approach we're going to follow. If we are
Okay,
able to
well,
generalize like huge piece of Kubernetes
I want to
related logic
understand
and
what benefits
Mhm.
you and Saad believe we get from the sidecar, because I did think little bit about like you know, if we go down the sidecar approach, then I think it's clear we'll need some sort of gRPC spec, and that's definitely more work, right? Because you need to write that down, agree on it, maintain it in a separate place, and then have a sidecar that conforms to it. I do see the benefit of it's much clearer where one stops and the other one ends, or where the one stops and the other one begins. But I don't I don't buy that libraries are way worse. Like I think that Golang used to have fairly bad versioning practices before modules were a thing, or what was the thing before modules when they had it properly versioned
Yeah,
imports? Um,
depths.
well, no, I'm not talking about that. I'm talking about like when they had proper versioning of import. Maybe it was Go modules, but if you buy the rules around how Go modules are supposed to work and how versioning is supposed to work, I think you can get a lot of the same kinds of benefits from them and say, okay, as long as I'm using the library version 1, it's got this interface, and if anything breaks, that's, you have to call it version 2. And then it's just a matter of, in my code when I'm importing, I got to choose if I import version 1 or version 2. And if we follow the the Go module versioning rules, I think you can stay out of trouble as far as like breaking someone. But it also doesn't lock you out of making breaking changes if, for the sake of forward progress, if you need to. You just have to version it with a major version bump, so that clients don't automatically get sucked into the new version when they don't want to. So
I think this is only part of the problem. Like in general, like writing Kubernetes controller is kind of is a relatively high bar for people who has like little experience with that.
Well, but my presumption is anyone who's writing a populator knows, more than the average programmer. I mean, these things are not supposed to be super trivial to implement, because we're talking about, pulling data out of somewhere and shoving it into a volume.
Right, but it might be a storage person who could have taken care of that, right? If we provided, like if we generalized all the Kubernetes part,
Yeah.
like we could just approach a storage person and say, oh, we need like a couple of interfaces you to implement related only to storage and don't bother with Kubernetes itself.
But so what you're describing is like we have an interface, we have a sidecar, and then we have a sample populator, and then you say, okay, Mr. Storage Provisioner, just fill in the blanks in this sample and you're done, right? And that's supposed to be very easy, which we could do, but like I think we could do the same with a library. You could have a library and you could have a sample populator that consumes a library, and just have a fill in this, fill in this, fill in this, sample, and then the rest of it you just use directly, and you get the same kind of benefit. I think. I hope.
Well, except maybe troubleshooting, but maybe you're right. As I said, like, I think at this point, maybe if we are not able to generalize right now or say how we can generalize logic, maybe library is a better approach at this moment to kind of to see what exactly we can generalize, how we can proceed, and then once we know more about that, we can generalize the entire Kubernetes piece. Then maybe we will be able to move that to a kind of a sidecar approach.
So let me talk about the specifics, because I started thinking about, well, if we were going to implement this interface, what would be in it? And the basic thing of like, okay, you need to supply a pod that's going to actually, mount the volume and stick the data in it, whether it's a file system or a raw block volume. Like that kind of integration is fairly easy, but there is one of the parts that would be hard to sort of do through a sidecar or do through a gRPC interface is that unlike CSI and COSI, the specific shape and form of the CR, that is the thing that you populate from, is defined by the populator. And that's like fundamentally it's a Kubernetes object, right? You have some CRD that you've created that says, this is my foo data source, and it has these fields, and this populator knows how to populate from foo data sources. And so if you try to imagine, okay, now we're writing up the gRPC spec that the sidecar is going to speak to the populator plugin, it's going to have to like send back and forth instances of this blob, which is defined by the populator, that are fundamentally that they are Kubernetes objects. We can massage them so that they look like something that you can put over gRPC, but at the end of the day, if somebody wants to define a CR which is really, really complicated and has lots and lots of subfields and options, they should be welcome to do so. But like how does the sidecar take instances of that and present it to the populator? It feels like a weird thing to do over gRPC, because we don't, one of the nice aspects of COSI and CSI are that, you don't need to know anything about Kubernetes to implement one of those plugins. But this is a case where you very much do need to understand that, like, what you're getting is it's a Kubernetes CRD, or it's an instance of a Kubernetes CRD, and you need to populate from it. And the way you're going to do that is by producing a pod that will either mount it or get a device, if it's a raw block, at a certain place, and then it will do something to populate it, right? And of course that something is the part that we leave undefined. But it feels like
that might be perfect reason to like start with the library. I agree with you that this is different than what we have with CSI.
Yeah.
And maybe we can find a good way to translate CRD into a typed object in Go. Maybe we can do that, but maybe we don't need to bother with that, at least right now. And just exactly, maybe you're right. We can just start with library and see later.
Well, I mean, crucially, when you go the gRPC route, you free people up to use programming languages other than Go. If someone wants to write a populator in Python and we have a populator gRPC interface, you could do that. You just have to talk, all the various gRPC interfaces from Python.
Yeah, probably I explained it wrong. So when you write a CRD, usually you start with a Go type. You then translate Go to CRDs. Actually, it's like as like normal way we do. I'm not sure like if it's a common way other people do. But basically, you have like Go code as source of truth, right?
That's the recommended way, but you certainly don't have to go that path. You absolutely can just write your own YAML and write your own client.
Yeah. I agree with you, Ben. Yeah.
So what I'm looking for is like, what is the other benefit of going with the sidecar, other than maybe cleaner separation? Because go ahead.
Yeah, I think that's basically really it. It's a cleaner separation. I think long-term maintainability becomes simpler because you have these independent components, and so if you need to rev one, you don't need to like recompile, rebuild, and push out images of your own code. You just go grab another.
Okay. So you're saying like I release foo populator 1.0 that uses library version 1.0, but then we find a bug in the library and we release library version 1.1.
Yeah.
Now I have to recompile foo populator to get that bug fix.
Right. And so it's just minor, but it's a convenience that sidecars give you. But I completely agree with kind of the concern that you're raising with the complication around having an arbitrary CRD and being able to pump that through.
Yeah. I mean, I guess worst case you could convert it to something like a JSON blob, or I don't know if gRPC has even the equivalent of a JSON blob. I mean, you could literally convert it to like text and then
Yeah.
force them to parse the JSON or something on the other side.
Yeah.
But yeah, those kinds of solutions feel gross.
Yeah.
Because then there's all sorts of input validation you have to do. And
Right. It's like we kind of want them to not care about the Kubernetes part at all, but in this case, we kind of do want them to care about the Kubernetes part. So
well, I mean, you know, with CSI and Cozy, we don't want them to care about Kubernetes, but I think this is a case where we're saying this is Kubernetes specific. This isn't
yeah.
meant to be reusable. This is just
So how about let's play devil's advocate here. What if we had a well-defined CRD where the set of fields was an opaque map similar to kind of storage class? Would that not work? What would it break?
Yeah, I think it's like with like opaque parameters is always like is probably not the best practice. When you
yeah,
lose
I
Yeah.
think
strong
that just
separation,
pushes
it's
the
like
ugliness. That pushes the ugliness into the Kubernetes API.
Yeah.
Whereas I think Kubernetes is well suited to say, oh, you know, you can define CRDs that have schemas and get type checking and all the nice things you get out of them. And so when you create like a, you know, we want to create a volume from like a GitHub repo and you define your GitHub repo as a type, you can put all the necessary things in there and get good type checking, and it looks sane.
Yeah. I mean, this is exactly the problem we're hitting as we come up with like Cozy. We're like, oh, you know what? One of the mistakes we made with Kubernetes or with PVC storage classes was we kind of had this opaque list of parameters. At that time, we didn't have CRDs. Wouldn't it be nice if a storage class could just point to a CRD, an arbitrary CRD? But then we realized like, oh, if we did that, then a lot of the way that our sidecars work wouldn't be able to work. And so for that reason, on the Cozy side, we decided, well, the benefit, the trade-off is not sufficient to kind of push through that CRD way. So we're continuing with the opaque parameters list until there's a better solution.
Okay.
But I'm not sure whether the trade-off here is the same or different.
Yeah, I mean, we absolutely could just have like a volume data source CRD, which everyone was forced to use, and then it was basically a string map, and you had to basically puzzle out from the string map what you were supposed to do. And that would sort of change the entire approach for the rest of this as well if we went down that path, because then we wouldn't need a controller, or we could just make a core change that said this is something, you know, that I guess at one point, maybe 2 years ago, there was a proposal to have like some sort of a generic populator object that I think would have looked like what you're describing now, some sort of just a string map kind of a thing, and that you'd have to figure it out on the other side. But I really like the more of a structured, you know, there's multiple different CRDs and they have fields that are defined, and
yeah, and I think it's more in line with the way it's currently worked, right? We have like volume snapshot is one data source and PVC is the other. So it's like it looks like if we just introduce volume snapshot PVC and then generalized version, it looks a little bit like
right.
Yeah, that would look especially weird to add it on top of two actual objects. So I like following the path of more actual objects, just open up the door to lots of them.
Yep, okay. I agree.
Okay, so we're happy with the idea of sticking with objects, and we recognize that would make a gRPC interface awkward, although maybe not impossible. So it feels like you guys would be okay with the library approach, or at least exploring that more deeply, because I haven't actually written the prototype for either of the two. I just started thinking about, you know, what would a gRPC interface probably look like? What would a library probably look like? And both of them seem possible, but the library seems like less work.
It feels to me like library is definitely a better first step, because we can always like separate library into a sidecar, right? We can say, okay, now this library entirely just goes into the sidecar, and here's interface like gRPC interface to introduce.
I am concerned about the layering that might evolve. Like once you have a library, you could have a style where like you take, you know, your plugin starts in main and it does whatever command line parsing it wants to do, and then it invokes like the library's sort of main event pump. But then it would have to supply all these like callbacks to say, in a, for basically supply handler functions for all the different events that could occur in the life of a populator, and then have implementations of those. So then you have this weird layering of like your code, and then the library code, and then your code, and then the library code, sort of interleaved, as you often get with libraries that have callbacks. And that's a perfectly reasonable design, I think, but that doesn't, if you go with that and then later you say, oh, I really wanted a sidecar, then you have to change everything, because you don't have things like callbacks and stuff in a
Well, I
sidecar.
think it's in detail. We can always, I think we will be able to structure and design the library so it works, reminds like the way sidecars work, but just code is like located locally. Maybe we will be able to do that. Like I think we could kind of try that.
Maybe.
Yeah.
It's hard to say without actually
Exactly.
doing some prototyping. And what I'm trying to do is avoid prototyping the wrong thing.
Yeah. I think I generally agree with Alexi. I'd say let's, one, optimize for speed of development, which means let's go down the library path. And two, as a North Star, let's at least keep the option of introducing a sidecar in our future. And that would mean that as we introduce this library, let's kind of structure it in a way where it would be possible to extract it out as a sidecar, versus completely not doing that and then realizing we have to re-architect everything later.
Yeah, I'm thinking like one of the pieces of code we'll need down at the bottom is like when it's time to actually populate the volume, someone's going to have to create a pod, and that code, of course, should be common code. Create a pod that, but like so what will fundamentally need to happen is like the populator code will have to tell the library code or sidecar code, like, here's my pod definition, or something like a pod definition. And so then you're also passing at least a template or a part of a pod definition from, through this interface. I don't know how much flexibility we'd want to give in the general case, but
got it. Yeah. I think if it becomes weird and odd, just lean towards whatever is easier for development. And for those edge cases, those will be, I guess, the decision makers as we can reconsider in the future whether we want to go down sidecar or not.
Okay, but I
Right.
guess
Also, another point is that maybe pod won't be even needed for some populators. I think Shing, like last meeting, mentioned that she had a use case where pod wasn't required.
So I wanted to get into that in my next topic, but just to mention one last thing about the one obvious downside of the library is that if bugs are found and fixed in the library, you'll have to recompile all the populators. So that's worth calling out as a downside to a library. Is there some, I guess, I don't know what you call that, just runtime maintenance issues around bugs. But yeah, I did want to get into the what if it's not a populator pod case, and in particular, like here we get much closer to specifically talking about backups, which I want to minimize how much we do. We get directly in backups in this meeting because that's more of a data protection topic. But backups are sort of my example for thinking about this. So the second topic I have on here is, let me just read it. The concrete examples for multiple ways to populate from a given data source. So let's go with the hypothetical. I have a backup object, right? Let's say somehow we've arrived at a place where there's a standard definition of what backups are. And lots of different CSI plugins are creating them. Things, we have implementations that know how to restore from them. Some of them are based on, just pods that know how to, take a snapshot and shove it into the cloud and then take it back out of the cloud and put it back in a volume. And other ones are based on some sort of proprietary implementation down inside the storage controller. So my thinking was that, if we had an object like that, where we wanted there to be multiple ways to create it and restore it or populate from it, we could do it in a way where we like one of the top level fields on the so-called backup object could be like the format. So like backups could have a format, and one format could be like, I am a tar ball in a bucket, right? Like that's pretty easy to understand. Like if you just tar up a file system and shove it in a bucket as an object, like lots of things could in principle generate that, and lots of things in principle could consume that. But there could be other formats that are way weirder. And so what you could do is you could have on your CRD that represented your backup, you could have a top level field called format, and then an individual CSI plugins that wanted to implement support for restoring backups could have a list of formats that they natively understand. And then when you got a request to create a volume from an object, normally the first thing that looks at that is the external populator sidecar. And today, it knows how to handle empty ones, and one's created from volumes, and one's created from snapshots, and one could imagine in the future, one's created from backups. But you could have special code for backups and says, okay, if it is a backup, we're going to look at the format field of that backup, and we're going to ask the CSI plugin, do you support this format? And if it says yes, then you call some other CSI function so that the plugin could just go handle it. But if it says no, the external provisioner could say, oh, all right, I don't support this one. I'm not going to do anything. And then
what do you mean by other CSI function? Are you talking about some new CSI?
Yeah, I'm imagining some new RPCs in CSI for managing creation and restoration of backups. Just as an example, right? I mean, there's lots of other things that one might want to, do with data population, but backups are one that's sort of, I think, on the top of all of our minds. But what I'm getting at is that like, you could have a field on the backup object, which was the format, and you could structure your CSI interface such that there was a negotiation between the sidecar and the plugin for the format, and only if the CSI plugin says, yes, I know how to restore from that format, then the CSI plugin would have the responsibility for creating the volume through the normal create volume path. You just supply the backup object and say, here, go restore from this. And the rest of it would be the CSI plugin's job, similar to like how it's done with a snapshot. But there would be an option to say, I don't support that format, so give it to someone else. And then the external provisioner sidecar could just do nothing. And in that case, it would be the administrator's responsibility to have some fallback populator that knows how to handle that format, and could just implement it for all of the storage backends that didn't natively support it. So you could have a mixture of supported backup formats where some were handled through CSI and some were handled through a generic path, and using some field on the object, you could have two different controllers sort of look at it and say, either I will do it or I will do it.
I like the idea. Sorry, go ahead.
I'm not sure about format. I like in my mind I have maybe it's not right. Imagine I imagine that as like we would have probably something similar to what Ben suggested, is like first party backups and third party backups. So first party is like storage system itself knows how to do that, and third party is like obviously it's everything else. And right, basically,
so that will exist no matter what we build. But the key that I'm trying to tease out here is that like whatever you build, the backup is in a certain binary format, right? Wherever it is. And if we can agree on at least some formats and standardize them, it creates the space for people to either have a generic implementation that works no matter what the storage controller or what the storage plugin is, or vendors can do something more optimized if they're able to.
I was more like under pressure that I wanted maybe to like whoever created backup is actually responsible for restoring it. So if we use specific like backup mechanism to create backup, it must be the same mechanism to restore that.
So I do like that's the simple way to do it. Go ahead.
Yeah,
Sorry.
no, I like where Ben is going with this, with the format idea. I would agree that it's not absolutely strictly necessary, and that you could always assume that the backup object created by a particular vendor is only kind of used and accessible by that vendor. But if we had an opportunity to potentially make a given backup consumable by multiple different vendors, that could be valuable.
Not sure we can generalize formats, to be honest. I think that that might be a trick.
So it may be the case that the vast majority of formats are proprietary, in which case the whole scheme degenerates into exactly what you described, where only thing that created it knows how to restore from it. But I would be sad if that was the best we could come up with, because I like the idea of having more standardized formats where, you know, maybe initially the only implementation of it is some general implementation in a pod that knows how to, you know, create and restore from that. But if we define what the format is and someone writes down somewhere, you know, a spec for it, then it would open the door to someone having a better implementation of the same format, and ultimately, you know, creating some collaboration and a, you know, interoperability between systems. And you know, in my really simple dumb case is, you know, a tarball in an object store, right? Like, you can write down what that is and anyone can say, oh, I know how to create that and I know how to consume that.
It's tarball and something inside tarball. Let's say it's CBT or something like that, right? Because format inside tarball, right? And also whether it's because maybe not everyone can read from every whatever, like object storage or whatever tarball is located. So it's like it's getting more and more complicated this way.
So the key is that the format just describes what it is, and then if the plugin thinks that it knows how to deal with that, it can do so, or you could decide not to. And you could have like, if one imagines you're actually designing backup, in addition to the actual backup CRD, there's going to be backup classes and other things that would allow an administrator some administrative knob to say, I want this backup class to be handled by this specific restorer and backer up, or whatever you want to call the thing that creates backups. And so if he happens to know that, you know what, all of my backups are in this standard format, but the object store that they go into is not accessible generically because I have weird firewall rules, then they could just decide, okay, I'm always going to use this particular implementation, regardless of the SP says it knows how to handle that format. But if there is the opportunity for things to interoperate, then they could choose to do it differently. And I don't know, there are some formats that are so easy that it feels like they really should be standardized and shared across multiple implementations, especially for like so think about the raw block case. How do you back up a raw block device? You just DD the bits into another bag of bits somewhere, right?
My point was, okay, we can find this one format which is like portable, like CBT based format, for example, right? And say, okay, CBT based format, but we know we have a pod for CBT based formats and it can handle CBTs. But if we take like first party backups like GCS, or sorry, PDs in Google, EBS in Amazon, they all have like proprietary formats. I'm pretty sure like many first party storages who do backups, they have their own format. So this will make our generalized format list like pretty big, and the only reason for that will be only one storage will support that specific format. So in that case, like, it kind of doesn't make a lot of sense in my opinion. I might be wrong here.
Well, but I don't think we need to have an enumerated list of every possible format, right? If you make this an opaque string,
yeah,
then it becomes more flexible without having to maintain like, oh, you have X different formats. It's more just a string matching thing than anything else.
Well, and I wouldn't say entirely opaque, but generally speaking, yeah, like it could be like a MIME type kind of a, you know, there's a well-known enumerated list, but it's extensible and you can add your own.
I see.
And then And yeah,
Yeah.
at the beginning, I absolutely believe that yes, each implementation will support exactly one proprietary thing, but I would just be sad if like that's the best we, if that's where we ended up at the end, where like everything was proprietary and not interoperable, and your backups you
I
could
think
only.
I think my point here, I totally I like your idea about having generalized like portable format. But I'm saying like we can standardize like one portable format, and we say this format is portable. It's, let's say, like just CBT based. And if you want to make portable, yes, you can do create portable backups and restore them on almost any storage system, right?
Well,
But
see,
if you use storage SIG
I
format, it's only for that storage system.
so here we are getting into the specifics of backup, which I don't want to do, but I also don't think that it's wise to believe that like we will choose the right standard format, because that's a whole difficult problem on its own, and I would rather create a place where multiple standard formats could in theory compete and the best one could win, if such a thing could happen. And CBT does sound like a relatively good way to do generic interoperable backups. Like, the ones I'm describing, like bag of bits for raw block volume or tarballs for a file system volume, those would have bad performance because they're fundamentally not incremental. They're always full copies of your data, and there's reasons why that's not a good way to do backups in general. But they're really easy to understand, which is why I like to throw them out there. Like the change block tracking, it's like, well, how exactly does that work? You have to define it, and it has to be a spec. Like tarballs are 1 million years old, so it's not there's not a question of what that means. So so getting back to the data populator specific part of this question, the main thing is, like, I think it would be smart to have sort of a way for there to be two different data populators that both understood the same CRD, and had a way to sort of arbitrate between them who was going to actually do the population. And so my example is for backups. The way you could do that is just have a format field, and then have the administrator define, or have the plugin have an interface to tell it, what formats do I support, and that you could use that as a arbitrator to say, okay, I have two populators, but ones with format X are going to be handled by populator A, and ones with format Y are going to be handled by populator B, and then you at least have a solution.
We can defer this decision to actual volume backup or backup populator.
And we should. I wanted to, because I think Xing was interested in this in particular. Like what about the ones where we don't want to have a full-blown pod do the work? So I'm trying to imagine, an example of a CRD where, when it's time to do the population, we don't want to just have an ordinary populator spin up a pod on a fake PVC and write the data into there and then rebind the PV, which is what the standard library would do. Like, if we had something where you wanted to implement it in CSI, you would have an extension to CSI, and you would have the code for that specific populator go into the external provisioner sidecar.
I think the good thing about the library is that you don't need to do anything you don't want in the library, right? So you use like the library may have much wider kind of scope than what you really need. And if you don't need something, you just don't call this.
Well, so help me imagine the third case. So I can clearly imagine the case of you use the library in the way it's intended to, to create a fake PVC in another namespace, to spin up a pod that does the actual work, and then you rebind the PV, that PVC gets bound back to the original PVC, and like that's one standard workflow. The second one is you just extend external provisioner to understand a new type, and external provisioner does what it normally does, where it just handles that type and passes the relevant bits through the CSI interface to a CSI plugin that does all of the work. What is the third case? Help me imagine another way to populate that's not one of those two.
So, well, our case right now, basically what we do right now, since we don't have this any volume data source yet. So we first call CSI driver to provision an empty PVC, and then we use that. We populate data. So if we have this, then we can have this.
But how do you populate it?
We have this API that can actually just write data to an existing volume that is already created.
Okay, so the behavior is you see the request to create the PVC from a data source. You create another empty PVC, just like the pod-based approach.
I actually didn't create another. So in my case, I don't really need to create like a fake PVC. Yeah, we don't need. So basically, I just create this one PVC and then I directly write data to it.
But if the user created a pod at the same time they created their PVC and to bind to that PVC, how do you prevent the pod from starting up?
That's what I'm hoping this can solve, because currently what we have to do is it's actually the pod is it's created later, right?
Oh, okay.
But I'm hoping with this that can solve my problem.
Okay. Well, yeah, and the way you solve it is with the fake PVC prime, and then you do all the population on the PV, and then you do the rebind, and that's sort of the trick that lets you have a working PVC that goes all the way through the path of external provisioner to create it, but any pods still can't bind to it because the PV is.
But if we have this, why can't we just hold it, like saying, wait until, so basically we don't bind them, right? Basically wait until this PV is populated. And then
I don't think I think an option here could be like use this initializer controller, or what's it, initializer pod or initializer container. Is that the right term?
You don't want to rely on init containers because like there may never be a pod, right? Someone could just create the volume and then take a snapshot of it before there's ever a pod and expect that snapshot to have the populated data in it. And there's problems when you have read write many PVCs and there are multiple pods that are all trying to connect to it. Like there's just a lot of really ugly issues that manifest if you try to sneak this population process into like the first pod to access the PVC model. I really like I think what Xing is proposing is like an entirely different way to sort of have maybe some change at the Kubernetes API layer that tells kubelet like this PVC is only half, or this PV is only half created, and therefore it's bound, but it's not usable.
I'm saying that it's possible that we don't bound it and we wait until we populate data to the PV.
I think that's what Ben's proposal currently is.
But I thought he's going to create like a PVC prime. So I was
well, he will.
A bit of that part, but
how would you create the volume if you don't?
Creating the PVC prime is the easiest way to sort of, with the existing Kubernetes API, get the behavior that we want.
Yeah, Xing, the behavior that you're describing, this is just an implementation detail of how to get that behavior. There are potentially other ways to get that behavior. This appears to be the cleanest and most robust one, such that if one of the controllers dies in the middle of processing, it would be able to recover. But if you have ideas for other ways to implement that behavior, that would be great to hear.
Yeah, I have to think about it, because right now we basically just hold off the pod until.
Okay. Well, so I want to think through the rest of your example with my implementation. So let's say what we're going to do now is go ahead and create the PVC prime, which is empty. It's another namespace that goes through the regular provisioner workflow and out pops an empty volume. The PV binds, except to PVC prime, not to the original PVC. Then you instead of creating a pod and binding to PVC
hold on a
prime.
second. Hold on a second. If we create the PVC, if it's if the provisioner, if the external provisioner does not handle it, then it shouldn't be bound yet, right?
Right, but PVC prime doesn't have a data source. That's the only difference between
Oh,
the original
okay.
PVC and PVC prime is
Right,
we remove the data source.
that's fine.
So that
It doesn't have the
yeah.
source. So how about I was trying to think. Can we actually just this populator, can it, when it sees the source, it just create a blank PVC first, and then
that's what PVC prime is. It is the blank PVC.
okay, but then
So
can we just use that? I mean,
yeah. So then
the real one. I guess that's my question. Can we not have another?
Can we not have another what?
Can we not having another PVC just to use this PVC prime at the end?
Well, I mean, so the user created his PVC and he's waiting for it to get bound. We don't want to change
user,
that.
right? This is, I'm talking about like a backup software is handling the creation of the PVC, not like a user, right? So
I think currently there is no way to kind of postpone pod provisioning, like or running when PVC is already there. So nobody will check like once
but the
PVC
external provisioner right now actually doesn't really. I mean, if it sees this any volume data source, it's not going to do anything, right? So then we can have our own data populator that creates a.
Yeah. So what the data populator would do in response to that PVC is it would create PVC prime. It would be the same except that there'd be no data source on it, so it's empty. And then the external populator will respond to that one by creating an empty volume and binding it to PVC prime. Then your populator could, in the first example, that I described, or the use case number one is you just go ahead and create a pod to bound to PVC prime that does the population. You're saying, no, I don't want to use a pod. My populator will then take the PV that gets bound to PVC prime and somehow look at the details of that PV, and it knows how to go straight to the storage controller and figure out which volume that is, and then it can directly put the data on it. That's sort of what you're describing is after you have an empty volume, you can go find it on the real back end and put the data on it somehow without using a pod and without using CSI, right?
Yeah,
so,
maybe that's how it has to be done. Yeah, I was.
If that's the case, why not just do that second mechanism that Ben said, which was you use the external provisioner, and the external provisioner recognizes that as part of provisioning, it's going to need to do some population.
Well, the issue there is we have to modify the CSI spec and add new RPCs and.
Not necessarily, right?
But if you do that, then you mean that everything will be done in the CSI driver, right? But that's not what we are doing here. So that is one path. If your CSI driver knows how to populate data, it already has that. But there's another case that CSI driver does not know how to populate. It actually needs some other like data mover.
So the data mover is different from your storage system.
Yeah, it's a different piece. So that's
okay. But the issue is the data mover would have to be able to take just the Kubernetes notion of the PV and figure out how to figure out what real volume on some real storage system that corresponds to, which means the data mover would have to understand the whatever the publish info is, or not the publish info, sorry, the CSI information in the PV.
It needs to know, it needs to, like in our case, it needs to know like the volume ID and the snapshot ID, those information.
Right.
Does not need to know that.
But that won't work in the generic case, right? So if you take like that data mover and point it at like a NetApp CSI volume, you're not going to figure out how to connect to that NetApp CSI volume just from
right. I was not really saying that. Yeah, I was basically saying how do I solve this a particular problem? How can I have like another data population solve this? I'm just trying to fit into this generic case.
But fundamentally, if you're not taking advantage of CSI's attach and detach mechanism, then the data populator itself has to be able to figure out how to find the volume just
Well,
from
because,
what the Kubernetes
well,
API has, right?
in this case, yeah, because in my case, I don't have to attach it, right? So,
Right,
but I
but you
do.
have to have enough knowledge that you could have attached it.
I don't need to, but the thing is, I still want the PVC to be scheduled on the correct. The final PVC has to be scheduled on the correct node, right? That I still need. So yes, still want
Yeah.
to have the.
So that would be the other benefit of this design, I think, is you could if the pod was like a wait for first, or sorry, if the original PVC was a wait for first PVC or wait for first consumer PVC, you could set up the PVC prime to similarly be that way, and you could sort of postpone the entire invocation of the population process until after there was a pod and after it had been scheduled, and then you may still have a pod that gets scheduled to the node for the population, but it could be a dummy pod, right? It could just be a pod that calls sleep, and then the real population happens directly.
We can still schedule a pod which actually does the population, but this pod doesn't work on attached volume, but talks to this whatever third-party backup storage. Right?
Something. Well, I don't know if the populator can from the PV definition figure out what to do, then you don't really need the pod to do anything other than exist on a node. Actually, all it needs is to get scheduled. Like once the pod has been scheduled, and then you can, and the rest of the logic that ensures that the CSI plugin that does provision the empty volume is passed the correct topology information. That's all that's really necessary, right?
But we don't even need to schedule this pod. If it doesn't work on the attached volume, then pod is not needed. Pod can just work with whatever backup.
But the empty
API.
PVC has to get created with the right topology information.
Right. We do have PVC. We do have PVC prime, but we don't attach it to any pod, right?
I was going to say the only way to fool the external provisioner into sending the right topology information is to have a pod bound to it. And
yeah, I don't see the hesitation against having the pod. It seems like it's a life cycle hook, basically, right? It's like saying, okay, we have created the appropriate empty volumes, and now in the life cycle, we need something to populate this volume. So we're going to kick off a pod, the populator pod. Whether the populator pod does the population directly and locally is an implementation detail of the populator. Or it can certainly call out to the back end and have that as the trigger. Whatever logic it decides to do inside that populator pod is up to the implementer of the populator. We don't care. Why do we want to kind of optimize or cut that out?
Yeah.
Yeah, I think that's fine. I was
I mean,
even though we don't require it, but if this scheduling piece actually require a pod to be there, then I think that's fine.
I think it does. I'm not. I haven't looked at all the code in the wait for first consumer implementation, but it
has to you have to have the pod first, right?
If we were designing this from scratch, we might decide to do it differently. But like right now, we have a working system that we're trying to have minimal change. So.
Yeah, it's pretty fine. I was mainly just saying that I don't need to do attach, but then if pod is required, I don't see that's a problem. It's
okay. All right, so yeah, we're almost at the top of the hour, and I think we covered both these topics fairly well. So I don't know what we need to discuss in the next meeting, other than I need to actually make more progress on prototyping. I've been busy doing a few other things, but I will write up the notes for this meeting, and we can tentatively plan on meeting again next week. And I don't know if we'll have any new agenda items by then, because it feels like we're, aside from getting the code written and some maybe updating the KEP and various specs, it feels like there aren't too many open questions. So I guess I would encourage you, if you guys have any remaining questions, please put them on the agenda for next week, because I am running out of things to discuss. I feel like I need to start coding soon.
Sounds good. Thank you for driving this.
Yeah, thank you guys. This has been really helpful just to talk everything through.
Thank you.
All right.
All right. Take
Bye,
care,
guys.
everyone. Bye.